Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Technogenier. In this lecture, we will study corona effect in overhead transmission line. If you see these figures, then you will understand that sometime due to the high voltage in the transmission line, some violet light appear, and this violet light is due to the ionization of the conductors which are used to transmit the voltage, and this violet light increases with the increase in the voltage. So these are this violet light is basically the corona. Now in this lecture we will study what is corona effect and the factor affecting corona, and then we will study the losses due to the corona in the transmission line. So what is corona? A corona is a luminous partial discharge due to the ionization of the air surrounding a conductor caused by electric field. So when the current flow in the conductor, there is an electric field appear around the conductor, and this electric field ionize the air, and this ionization of the air create corona effect. According to a theory of cloud electrification, such as corona is not only the effect but also the cause of appearance of the charge of the cloud, thus of the lighting and thunderstorm. So when the clouds are charged clouds strike each other, then the light which appear or the lighting which appear, according to a theory, it is also called as a corona effect. A corona on a transmission line cause power losses in terms of buzzing sound. So we can hear some buzz or hissing sound or some frying sound in the vicinity of the line. At high voltage level, that is 345 or higher voltage level, the conductor itself is a major cause of the corona effect. So when high voltage transmit in a transmission line, then the field around the conductor is ionized, and this ionization is appeared in the form of a light, and this light is basically the corona effect. So many tests show that the dry air at normal temperature and pressure, uh, uh, like 25 degrees centigrade and 76 barometric pressure, break down at 29.8 kV per centimeter. That means that when we have voltage above 29.8 kilovolt at 25 degree and 76 pressure, then this the air will be braked, and the corona effect may occur. There are always a few free electron in the air due to ultraviolet radiation from the sun, cosmic rays from the outer space, radioactivity of the earth. As the conductor becomes energized on each half cycle of the AC voltage wave, the electron in the air near its surrounding are accelerated toward the conductor. If when there is a positive half cycle, the electron move toward the conductor, and when there is negative half cycle, the electron move away from the conductor. So this process is called ionization. The velocity attained by the free electron is dependent on the intensity of the electric field. If the intensity of the electric field is high, then the velocity of the electrons are also high. But if the electric field is low, then the velocity is also low. And this intensity gradually decreases with the increase in the distance from the conductor. So if the intensity of the electric field exceed at a certain critical value, any free electron in the field will acquire sufficient velocity and energy to knock one of the outer orbit of the electron clear out of one of the two atoms of the air molecules. This process is called ionization, and the molecules with the missing electron is called a positive ion. Okay. It has its maximum strength at the surface of the conductor, and its intensity diminish inversely as the distance increase from the center of the conductor. So if the distance of the from the conductor is increased, then the ionization decreases. That means that these ionization process is usually near or around the conductor. When the distance increase, this ionization process is decreased. Thus, as the voltage level in the conductor is increased, the critical field strength is approached, and the initial discharge take place only at the near the surface of the conductor. So now there are three major things in corona. We can see corona visually, which appear as a violet colored tuft and streamers, or a glow around the conductor, being more or less concentrated at a irregularities on the conductor surface. If you see the figures, you will understand that due to the high voltage there is some glow around the conductor. This glow is basically corona, and it is in usually in violet color. The second possibility to check when the corona occur is due to that is audible corona. First one is visible corona, visual corona. The second one is audible corona, so which appear by a hissing or frying sound whenever the conductor is energized above its corona threshold voltage. The sound is produced by disturbance set up in the air in the vicinity of the discharge, possibly by the movement of the positive ion as they are suddenly created in the intense electric field. The corona phenomena is also accomplished by the order of the anon. This is the third thing which we understand, that we can check that the corona effect occur when we see some violet light around the conductor. The second thing is that when we hear some buzzing sound, then the corona effect may occur, or we smell some odor of the ozone. That may occur due to the moisture or nitrous acid, and if the corona is heavy enough, the corrosion of the conductor will occur. So the corona degrade the quality of the conductor. That is also a loss in the conductor. So you should keep in mind that there is always a power loss associated with corona. Furthermore, the charging current under the corona condition increases due to the fact that the corona introduce harmonic current. Because when the charging when the charging of the air around the conductor increases, the harmonic in the system also increases. And so you should keep in mind that the corona effect increase the harmonic in the systems. And harmonics are basically degradation of the power quality. If there is some current harmonics or voltage harmonic, then the pure sinusoidal wave is disturbed, and some kind of different kind of wave may appear, and that is due to the harmonics in the conductor. So as a thumb rule, if the ratio of the spacing between the conductor to the radius is less than 15, so the spacing between the conductor and the radius of the conductor is less than 15, then it is confirmed that corona may occur. So ideally, or in practical practice, we do not use conductors. We do not reduce the spacing between the conductor, and it is always greater than 15. So this is not possible, and when we design a transmission line, we always consider this factor in our mind. But at a given voltage, the factor affecting corona includes line configuration, conductor type, conduction condition of the conductor surface, and the weather. So there are four parameters which affect the corona. Number one, line configuration. Second one is conductor type. If the quality of the conductor is different, or the size or the diameter of the conductor is different, then it may affect the corona. See, if there is some irregularity in the conductor, then it affects corona. then if there is some moisture or some dust particle at the surface of the conductor, then corona may occur. And finally, if there is high temperature, or there is high pressure, or any in any irregular atmospheric condition, then corona may occur. Now, in a horizontal configuration, the field near the middle conductor is larger than the field near the outer conductor. So if you see that when we have three conductors in a horizontal formation, then the field at the middle conductor, because this field in the middle conductor is affected by the फील्ड इन द राइट साइड एट द, यानी कि अगर आप इसको इस तरह समझें कि तीन कंडक्टर्स हैं और जो सेंटर वाला कंडक्टर है उसके ऊपर अगर आप फील्ड को देखें तो वो सबसे ज़्यादा होगी, क्योंकि जो राइट साइड वाला कंडक्टर है वो भी उसको इफेक्ट कर रहा है और जो लेफ्ट साइड वाला कंडक्टर है वो भी उसको इफेक्ट कर रहा है। तो इस तरह क्या होगा कि जो मिडल कंडक्टर है इस पर सबसे ज़्यादा फील्ड इफेक्ट करेगी। तो इसका इफेक्ट क्या होगा? द डिस्ट्रप्टिव क्रिटिकल वोल्टेज इज लोअर फॉर द मिडल कंडक्टर, causing larger corona loss than the one for the two other conductor। इसका मतलब ये हुआ कि ना जो सेंटर वाला कंडक्टर है उस पर ज़्यादा कोरोना होगा एज कम्पेयर टू राइट और लेफ्ट कंडक्टर। अब क्या है कि द कंडक्टर हाइट इफेक्ट द कोरोना लॉस, दैट इज द ग्रेटर द हाइट द स्मॉलर विल बी द कोरोना। So height is a major issue in corona. Say the more and other factors are the corona losses is proportional to the frequency. If the frequency is high, corona losses are high, and if the frequency is low, then the corona losses are low. That means that in 50 hertz, corona losses are less than the corona losses in 60 hertz. So the corona loss at zero frequency, that is in DC, is far less than the corona loss in AC. As you know that in DC there is no frequency, so the corona losses are very low. Similarly, the irregularity of the conductor surface in terms of scratches, raised strand, dye burrs, dye grease, and the particles of dust and dirt that clog the conductor can significantly increase corona। ये बात अब आपने याद रखनी है कि जो सरफेस है जितना स्मूथ होगा उतने चांसेस कम होंगे कोरोना के, और जितना रफ होगा उतने चांसेस ज़्यादा होंगे कोरोना के। Now, the breakdown strength of the air varies with the temperature condition. The breakdown strength of the air is directly proportional to the density of the air. The air density factors are, अब ये जो आप देखो डेल्टा बेसिकली क्या है, वो क्या है 3.9211 इंटू पी डिवाइडेड बाई 273 प्लस टी, दैट इज अब पी बेसिकली क्या है प्रेशर एंड टी इज़ द टेम्परेचर। तो ये ब्रेक डाउन स्ट्रेंथ है एयर की, ये भी फैक्टर है कोरोना के लिए। यानी कि अगर हमारे पास प्रेशर बढ़ जाता है तो चांसेस जो होंगे कोरोना इंक्रीज़ करने के, इसी तरह अगर टेम्परेचर बढ़ जाता है तो ये कोरोना डिक्रीज़ करेगा। यानी कि जो breakdown strength of air is directly proportional to pressure, but breakdown strength of air is inversely proportional to temperature. And now the second formula is the minimum voltage at which the ionization occur in fair weather is called the disruptive critical voltage and can be determined by, if you see this one, E naught is equal to V naught divided by R into natural log D by R, and V naught is equal to E naught into R into L and natural log D by R. So E naught, what is E naught? E naught is the value of the electrical stress at which disruption starts in kilovolt. So it is the electrical stress of the conductor. V naught is the disruptive critical voltage to the neutral in kilovolts. R is the radius of the conductor and D is the diameter of the conductor. Since in fair weather condition, E naught of the air is 21.1 kilovolt per centimeter. That means when we have 21.1 kilovolt, so this is the minimum voltage at which the corona may not be occur. When the voltage increases from this voltage, the corona may occur. But so we can use V naught is equal to 21.1 into R into natural log D by R. So we are putting the value of E naught, which is correct for normal atmospheric pressure. That means we have 76 uh, in, atmospheric pressure and 25-degree temperature. But if the temperature or the pressure is different, then the formula will be V naught is equal to 21.1 into delta into R natural log D by T K V. Now this is an example. A three-phase overhead transmission line is made up of three equilaterally spaced conductor, each with an overall diameter is 3 centimeter. The equilateral spacing between the conductor is 5.5 meter. The atmospheric pressure is 74 centimeter and the temperature is 10 degree. If the irregularity factors of the conductor is 0.9, in each case determine the following. Number one, a disruptive critical RMS line voltage. Now from equation 8.1, delta would be 3.9211 into P divided by 273 plus T. So the delta value is 1.0253 and V naught value is 21.1 into delta into M naught into R into L and D by R. So when we put these values, so the voltage which we get is 172.4 kilovolt per phase, and V naught is under 3 times the voltage, so the voltage is 298.7 kilovolt. So if the voltage increases by this one, then the corona effect may occur. Now, according to the peak, this is a reference. Scientists did a research that the fair weather corona loss per phase or the conductor can be calculated. So this is the power loss, and power is 241 divided by delta into frequency plus 25 R by D under root V minus V naught square into 10 raised power minus 5 kilowatt per kilometer. And this is another formula, that is 390 by delta F plus 3 R over D 1 by 2 V minus V naught into 10 raised power 5 kilowatt per mile. So this is in kilometer and this is in mile. F is the frequency, V is the line to neutral voltage, and V naught is the disruptive critical voltage in kilovolts. Now, according to Peterson, this is another researcher, the fair weather corona loss per phase or the conductor can be calculated. This is another formula by another researcher, that is it is 1.11066 into 10 to the power minus 4 divided by natural log 2 times D by D into F into V square into F. And limiting factor for extra high or ultra high voltage, then this is the formula. D is the conductor diameter, capital D is the spacing between the conductor, F is the frequency, V is the line to neutral voltage, and F is the corona factor determined by the test and is a function of ratio of V to V naught. So this is an example. Consider example 8.1 and assume that the line operates at 345 kilovolt and 60 hertz and the line length is 50 miles. Determine the total fair weather corona loss for the line by using peak formula. So this is the peak formula. So based on this formula, we can calculate PEC. When we put a value of frequency delta R D V and V naught, the value would be 12.1146 kilovolt per mile per phase. So this is the power loss. For the total length, when we multiply it with the length, then it is 605.7 kilowatt per phase, and the total corona loss is, because there are 3 phases, so we have to multiply it with 3. The total loss is 1817 kilowatt. So this is a huge power loss. Thank you, Jazakallah. Hopefully you will understand the basic things of corona and the factor affecting corona and what are the losses due to the corona. Thank you.